Imagine placing a living cell into an environment so intense that the pressure becomes 1,000 times stronger than the air around you right now. It sounds almost impossible, but scientists have actually studied conditions like this in high-pressure laboratories. The question is simple but fascinating. What really happens to a living cell under 1,000 atmospheres of pressure at normal conditions? A cell is a delicate but incredibly organized system. It has a protective membrane, thousands of proteins performing chemical reactions, and DNA carrying instructions for life. Everything inside the cell depends on balance. Molecules move freely, enzymes fold into perfect shapes, and energy flows through tiny biological pathways. But when pressure starts rising, that balance begins to change. The first thing affected is the cell membrane. This thin layer acts like a gatekeeper for the cell. Under extreme pressure, its molecules are pushed tightly together, making the membrane less flexible. When that flexibility decreases, the cell has a harder time controlling what enters and leaves. Inside the cell, proteins begin to feel the pressure. Proteins are like microscopic machines that only work when they keep a precise shape. When pressure becomes extremely high, water molecules push into their structures and disturb those shapes. As a result, important chemical reactions start slowing down. DNA, the instruction manual of the cell, also becomes more compact. This makes it harder for the cell to read genetic information and produce new proteins. Interestingly, some microorganisms can survive incredible pressure, especially those living deep in the ocean. These organisms, called piosophiles, have evolved special structures that allow their cells to keep functioning where most life cannot survive. However, at around 1,000 atmospheres, most cells struggle to continue normal activity. Metabolism slows dramatically, movement inside the cell becomes restricted, and biological systems begin approaching their limits. Studying these extreme conditions helps scientists understand the resilience of life and how living systems might survive in the most unexpected places in the universe.